we can always put this on later, so I'll put it on for you to watch. I'll put it on YouTube. Okay, so just be careful because your messages are recorded as well, so be careful what you put in there. Right, so far, oh. Entire screen, okay. Hi Ryan, nice to see you. Okay. Obviously, because I haven't seen you for a while. Good to have you back. Okay, so hopefully you can see my screen. Let me stop, just I'm not sure what I presented, I wasn't thinking. Okay. It's this one I want. Okay. So this is my view of all you guys. Right. Excellent. So, hello, Rebecca. Right. Okay. So let's get on with some work. Cool. Okay. So if we look at the whiteboard here, hopefully you can see my little whiteboard. This is just a little whiteboard in front of the classroom. And what I'll do at the end, I'll just clear this because I did it with another class there. Clear my canvas. Okay. So here's a nice whiteboard. So today's lesson we're going to talk about something called the pH scale. Now you don't need to worry about what pH stands for. Do you know why I'm not going to tell you what pH stands for? Because the scientists who come up with it can't remember what it stands for. Okay? It's something to do with the hydrogen ions that are in acids and alkalis, but there's lots of scientists now arguing. You know, it's like you come across something that's really funny, like the funny joke. Oh, I wrote that joke. No, I wrote that joke. No, I wrote that joke. Right? They're all saying, well, no, I wrote it and it said this, and I wrote it and it said that. So we just call it the pH scale. As long as you know what it does, you don't need to know what pH stands for. Okay? There's lots of different theories on it. But just think of it as the pH scale, small p, big H. And it's to do with acids, and it's how acidic or alkali a subject is, a substance is. Okay, now it works it like this. Okay, low numbers are very acidic, and it only goes up to 14. So numbers towards 14 are alkali, and in the middle you've got 7. Lucky number 7. He's neutral. So things like water are neutral. Remember all the things, vinegar, all that kind of stuff we talked about were maybe pH 3. So this is the scale. Now, how do we know whereabouts the scale is? Well, there's electronic machines which can tell you. They can tell you where it is. However, we don't have those electronic machines in school. We've got pH meters. So I'm going to watch a little video together. And it's in here so you can watch it later on. Once I find the classroom, here we go. So you guys can do this yourselves later on, but I'm going to have a little go first. Don't do this now. If you've done it, it's fine. But I'm going to have a little go myself here, right? And you guys can do it with me, and then you guys can do it yourselves after. Okay. Right, so hopefully you can hear this.
This is Pratibha, and I'll be teaching you the next part of this chapter. So hopefully from last week you have learned a lot about acid and alkali indicators. In particular, I hope you have learned and remembered the litmus papers and how they can tell us whether some substances are acidic,
there's no video there, is
alkaline, or...
It's not working on my...
Consider this example.
Here we go.
2 people are fighting. Okay, one says kiwi juice has more acid, is more acidic. The other one says no, orange juice is more acidic. Now, who is correct? How can we find out which fruit juice is more acidic? That's where our universal indicator comes in. Now, what is universal indicator? It is a liquid mixture that contains several different indicators. Because it's a mixture of different indicators, it's going to show a different color depending on what you mix with it. So, depending on how acidic or how alkaline the substance that you're mixing is going to show a slightly different color, as you'll see in the next few slides. And we have something in paper form that is essentially the same thing as universal indicator, but just in a paper form for convenience. Because universal indicator can be messy, it is a liquid. All right, so let's see what they look like, both of them. Okay, so this is the universal indicator, and in the lab you will see something like this. And this is the pH paper. Again, both of them work the same way, they're just different forms. And the number you are seeing.
So in class, guys, when we do it, we'll have these little bottles. Now, obviously, you need to be careful because it stains your hands. It's lots of different little indicators in it that turn a different colour depending on how acid or alkaline it is. And perhaps when we get back to school, we shall make our own indicator out of cabbage, red cabbage, because red cabbage turns red in acid and blue in alkaline. Okay, in fact, the chemicals that are in it are actually used in this as well. But we can have it in paper form. It's just this is impregnated in the paper, and here's a colour chart. We just dip that into the substance, and then we look at the chart to see where it comes. Yeah. Okay.
Seeing here actually refers to the pH values. So if I dip one of this paper into a fruit juice, it's going to give me maybe, for example, this color. It's going to turn into that color, orange color. Then I know the pH of that substance is pH 3. So that's how it works. We just dip this paper onto our substance and we can quickly get a sense of how acidic or how alkaline that substance is. Okay, now moving on. As I mentioned this already, now the pH scale, what do those numbers actually mean? So there's a whole scale called the pH scale, and it starts from 0 and ends at 14. So substances that have pH.
Okay, sometimes you see with the zero, the ones we were doing only go from 1 to 14. Okay, so sometimes you might see it with zero, but the one we're going to do only goes from 1.
0, the red side, very low pH, right? It means it's highly acidic, highly acidic. Substances that have pH 14, they are extremely alkaline, extremely alkaline. So the lower the.
So if you're colourblind, obviously you're going to struggle a little bit, especially between the red and the green. So might need to use an electronic one, or get your partner to show you if you, because lots of people have red-green colour blindness. More rare in girls, but it's quite common in boys. Okay, so just be careful with that. But what we'll be doing is we'll be testing stuff, and we'll be seeing what colour it turns the paper, and then we'll be putting on that. Yeah. Okay.
The number more acidic. So anything below 7, okay, we classify them as acidic. Okay, so we would call all of these acidic. Anything above 7, we would classify that as alkaline. So that's why, for example, most of your cleaning substances in daily life and the lime water that you saw in a carbon dioxide test, all of those are alkaline because they're above the pH 7. What about pH of 7 exactly? If pH exactly equals to 7, then it is neutral, neither acidic nor alkaline. Okay, so let's do a review. Lower the pH value, the more
acidic the substance.
acidic the substance. The higher the pH value, the more alkaline the substance. And a neutral substance has a pH value of 7. Okay, I hope you understand all of that. If you don't, feel free to pause the video and then rewind and watch it again until you understand.
Okay, so
now turn to page 22. Get ready.
So going through here, it's going to talk about some stuff, right? So if we stop this now, okay, that's there for you to work through on your own, but we're going to do some stuff ourselves. So let's look at the PowerPoint now. Okay. If I download it, again, you've got this to look at yourselves. Okay, so I'm going to go through that. Just a little introduction there in case anybody missed the lesson. So I'm going to download this and open it up. Hopefully we can all see it. Hi Jack, you alright? Spaceman behind you. Spaceman. There's a spaceman behind you. Okay, I can see you in outer space. Right, so this is the one we're going to work on today. Right. Okay, and then we're going to get a little worksheet to do in about 20 minutes. Okay. Okay. Okay, so imagine we're in class. I'm going to talk you through what we're thinking here. Okay. Oh, God, it's warm. Right. So one of the things, the pH scale is a measure of the strength of acids and alkalis, yeah? Okay. So an indicator is just something that shows you what's happening, yeah? So we might indicate to turn the car, or we might use lime water to show if there's carbon dioxide in there. Here we've got universal indicator. It's called universal because we have some types of indicator which only show acid or alkali, whereas this shows acid and alkali and how acidic or how alkali the substance is. So an indicator, we can use an indicator to find out a substance acid or alkali. Okay, and here's one we're going to make in class. So we're going to get some red cabbage, going to chop it up, going to mash it, going to boil it, going to get the liquid and make our own indicator. And then we're going to add some acids and neutral and basic stuff or alkali stuff in it. And it's going to give us a scale. So we can look at red cabbage scale. Okay. However, other ones we might use is litmus paper. People have heard the litmus test. The litmus test. Yeah. Oh, hold on. Sophie's just typed in there, I don't get it. Okay, Sophie, tell me what you don't get. Come online, tell me what you don't get. Because tell me what you don't understand.
I just don't understand anything.
Are you listening?
I am listening.
Okay, right. So good. So you stay on the line and you listen to me, right?
Okay.
Right. Now, when we did the whiteboard, where's the whiteboard? Right. Now you've done all the lessons about acids and alkalis, yeah? Sophie, did you do all the lessons in acids and alkalis? Are you still there? Hello? Sophie, I can't hear you. Sophie, you need to turn your mic on. That's better. So this will help, Sophie, this will help everybody, because if you don't understand, then that's good, because it will help everybody.
Okay.
So you've done the lessons in acids and alkalis, haven't you? No, you didn't do the lessons?
No.
No. Okay, so what you need to do then is go back and do those lessons that you missed. Otherwise you won't understand. They're all on the Google Classroom. You need to go and look for them and look through them.
Okay.
Yeah, will you do that for me? Okay.
Yeah.
Right. So acids and alkalis are things that we get every day, aren't they? Yeah, we see it. Do you remember looking at home and finding some toothpaste and stuff like that? Sophie, I need to know what you don't understand so as I can go on. Tell me. You understand? So you've got something that's an acid and an alkali, and we've got a scale. Yeah? Like some.
Yeah.
So you want to find out how heavy something is. How would you do that?
By measuring it.
Measuring it using scale, wouldn't you? Well, this is just the same thing. We want to find out how acidic or alkaline something is, and we're just using a scale. It's just new to you.
Oh.
You don't get it. It's new to you. So it's just the same as measuring stuff. It's a way of measuring acids and alkalis. Does that make sense?
Yeah, it
Okay.
does.
Listen, Sophie, well done. Thank you for stopping it so we can move on, yeah? Brilliant. So, Sophie, you also need to catch up on any lessons you missed, otherwise it won't make that much sense. But you happy? Can we move
Yeah,
on?
I'm
Right.
happy.
Brilliant, brilliant. That makes good sense. That's good. Okay, where's my PowerPoint? Okay, so back on the PowerPoint, we've got cabbage, right? So one of the things that we can do in class, and it'll make more sense when we're sitting in class and we do it, we get the cabbage and we chop it up. We can make our own scale. So say, for example, in class, we wanted to make some measurements of how acidic something is. Well, we can't use weighing scales for that. We can't use a ruler. We need to use something chemical to do that. And this is just like a chemical scale. Yeah? So if you imagine something's heavy or something's light, yeah, we'd put it on the mass scale and find it that way. This is just telling us if something's acid or alkali. Okay? Right? Now, the one we're going to use, talk about today and tomorrow, or today and Wednesday, is universal indicator. It's called universal indicator because it does everything from number 1, which is an acid, to number 14, which is an alkali. And it does that by giving a different colour for a different number. Okay, so if you look here, we put this substance into the test substance, put this into the test substance, and then it changes colour. It'll go red, orange, yellow, green, different shades of green, different shades of blue, all the way up to purple. And depending which number, which colour it goes, depends on the number of the scale. Yeah, that's all that is. Okay, so if a substance turns an indicator red, it must be an acid. Courtney, do you want me to turn my cam off? Is it because my hair's a bit dodgy, is it?
No, sorry, sir. I meant the chat because people keep sending rude comments to me.
Okay, let me see who's put a rude comment. I'll turn the chat off. Yeah, there you go. Chat's
Thank you.
You're welcome, Courtney. Okay, so chat's off. So if you need to speak or ask anything, you need to put your hand up. Yeah, click your hand up in the meeting. All right. Okay, so something turns universal indicator red. So we don't know. We look red. We look at the scale. Turns it red. It's an acid. If it turns it blue, it's an alkali. If it turns it green, it's in the middle. It's neutral. Okay.
It's an acid.
Yes, well done. Who shouted that? Who was that?
It was Daniel.
Daniel, well done, Daniel. Thank you. Excellent. Okay. So, if something's got a pH of 5, how would you describe it? So if we look at the scale, pH 5. Ooh. Matthew.
It is increasingly acidic.
Well done. So it's certainly acid, but it's not massively acid yet. It's slightly acidic. Well done. Thank you, Matthew.
I said I keep you that enough.
Saw that back. Hi, Sophie.
Hi, sorry, sir. I accidentally left.
Oh, you're back. You're back. That's good.
Yay.
Okay. So I tell you what, just for you, Sophie, then, because you probably missed this question, right? You can answer this one, just you. Somebody else knows the answer. For substance terms, universal indicator, bright red. We don't know. We look at it. Look at the scale. Bright red. We can see it's an acid. Yeah.
Best, and then circumstance.
Yep. Does that make sense? Okay.
A bit.
Yeah, brilliant. Good.
Sorry, sir. I accidentally left.
Is anybody accident? How can you accidentally leave? That's like getting up and walking out the classroom. That's fine. I do that all the
Internet.
time. I've shut the meeting down before. Okay. Wouldn't it be nice to have like a shut up button in class? Wouldn't it? Just press a shut up button. You lot. Boom, 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 boom. Great, and I can just turn my speaker off here. Anyway, right, let's carry on. So, which colour? Okay, guys, so in the chat now, I'm going to put the chat back on, so no silly comments, and I'm recording this, so everything will be here. I'll have a look at it later, Courtney, right? So anything that you put is being recorded, right? Now, what I want you to type in there, a colour you would expect a strong alkali to have. So I'm going to show you the indicator, and you tell me what colour a strong alkali might be. Just type it in there. Strong alkali. So remember, the nearer the middle it is, the weaker it is, the nearer the edge it is, the stronger it is.
Purple.
But don't shout out the answer. I want you to type it in. Brilliant.
Sorry,
Lovely.
miss. Sorry, sir.
Okay. Sorry, miss. Sure. I know my hair's getting a bit long. Right. So purple. Well
Sir,
done.
you turned the chat on.
Right. Only because I want people to answer. So Sophie, did you get that was that answer? What did you put, Sophie?
I put purple. The same.
Excellent. So you're starting to get it now, yeah?
Yeah, Emma. Yeah.
Brilliant. Brilliant. That's cheered me up. That was cheered me up.
Yay.
I was worried about you for a minute then. Okay. So you're doing well. Okay. So absolutely right. Those you who put, we'd expect 12 to 14. 14 is really strong, and these are strong alkalis, yeah? Okay. What would have a pH of... Oh, right, so let's look at... Water would have a pH of... Actually, the answer. Just type in a number. Type in a number. Well done, well done, well done. Excellent. Somebody knows neutral, neither acidic nor alkali. So two ways we can neutral. We can use just water. Water's neutral. Or we can add an acid and an alkali, and it goes towards middle. So if we got an acid down here, and we add alkali to it, it moves, the colour changes, and it goes all the way down here. We'll practice of that. Okay. Okay. So, substance of 14, acid or alkali. Type acid or alkali in the chat. Substance pH 14, acid or alkali. What do we think? Well done, everybody. Well done. Lots of you type that. So you're getting this. You're getting this. It's really good. Okay. You believe how many year 10 and 11 students forget this, right? So it's just a scale to tell us how acid or alkali something is. And we're going to do a practical lesson on it as well. Okay. So the three indicators we use to test pH, we can use a cabbage indicator, we can use a litmus paper, but the one we're concentrating on over the next couple of lessons is universal indicator. Okay, so if we look at everyday items, okay, we can use litmus paper and universal indicator to identify different substances. So we can record observations and put them in a table. So we'll do that when we get back to class. Okay, now here's Barry, right? Barry's eating his dinner, right? What was the pH of your mouth as a normal? What was the pH of Barry's mouth at normally? What's it normally, looking at the graph here? Okay, so we're looking at the pHs on this side, and this is time passing on this side. Okay, what is the pH? So we look at the graph and we look across and we see what's the reading. Okay, so what she said, it was 7. So he starts to eat here, and look what happens. to the pH in his mouth. Okay, what happens to it? Does it become more acidic or does it become more alkali? Who thinks it becomes acidic? Who thinks it becomes alkali? Type in what you think. It become more acidic or more alkali? More acidic, Jamie. Well done. So Jamie, straight away come more acidic. Now, one of the things that acid does is it eats away the enamel on your teeth. So if he doesn't brush his teeth, what's that going to do to his teeth? The acid. It's going to make him have to go to the dentist, isn't it? Okay. So pH of 7 is neutral. Okay. And the pH after he ate the meal became more acidic. Okay. So that's why we need to, right? Now, he chews special gum after each meal. The gum neutralises liquid in his mouth. So if it neutralises the acid, it might be an alkali. So we're going to stop there. I think that's as far as we need to take this today. We can do a bit more tomorrow. Who's putting it? Courtney. Oh, Courtney, what are you doing? Yay. Right. Okay, so next thing we're going to do is look at the lesson here. Go back here. Right. What I want you to do, don't worry about the head puzzles there for you to do if you want to. The next thing you got to do is you've got a little exercise to do, which I'm going to leave you guys to do on your own. I'll be fine with that. Right, so you need to log in using your school account and you'll find this worksheet here. Now again, if you need to make it bigger, you can zoom in. Okay, and all we're going to do is you click on one and then you think, so pH, what is it? If you don't know, you can, there's a couple of links on here to help you. pH of common substances will take you here. So we look down here, milk tells you. So you can back into your thing. Milk is acid, so I might choose something acid. So milk, something acid. It's not very strong acid, is it? Okay, acid rain, that kind of stuff. Okay, then what we're going to do is we're going to put the colours. Who's put the hand up? Emily.
So we have to log into Edpuzzle.
No, Edpuzzle's only there as a starter, as in case people are running late, and it's there for you if you finish this worksheet really quickly. All right?
Thank you.
Yeah? Okay. So the idea is that you're going to try and work out the pH of each of these guys and put it in there. The other thing, the more important thing, doesn't matter if you get these right or wrong as long as it's in the right direction, right? The other thing I want you to do is when you're on it is to choose a colour. So I'm going to choose purple and I might colour this in. Oh, I don't want that. So if I click on here and then, in fact, I might make it a highlighter. Then click on purple. I can highlight this. Oh, still wants me to do that. You need to do the fill in thing first. So if we do all that first. I'm not giving you the right answers, by the way, I'm just doing it first. Okay, so hopefully I can start to colour it. Oh no, it's not letting me do that. Okay, so you might need to, I'll just try to think how to do that. Okay, so down the side here, we can do it like that. Yeah, we can put the colours like that. Cool, that's good. Right, so what we need to do, guys, is if I undo that, right, you choose your colour. So say, for example, you wanted to highlight that purple, do the first one for you. You click on your highlighter, click on the purple colour, and then you, oh, too high, click on the highlighter, and then, yes, it's going to let you do that. Yeah? So you might put a purple one through it, let's put a blue one through it. Yeah. I wanted purple, so put purple. Yeah. Anyway, you guys will work it out, I'm sure. Don't worry if it doesn't work too well. So the idea is you're going to colour these all in the right colour. Let me get it working properly. Right, so if I click on the highlighter and I click on the colour purple here, That's giving me a highlighter. I can highlight here. Lovely. And then I can click on a different colour. I can click on blue. I might put that here. Oh. Oh. I need to come off it. And I might want to put blue here. Oh, too high. Let's move it down a wee bit. Here we go. Blue there. And then, so click off it. And then, yeah. Noah.
So I've done the worksheet, but I haven't highlighted it. I've just put a line to
If you want to just write the colours in, you can. But I'm just trying to colour it in a little bit for us, so just to see. So I want to put 7. So it's this one here. We need to colour to go dark, sort of mid green there. Yeah, and then I might put lighter green below. As long as you show how the colours are changing. I might put yellow here. And then I might put red down the bottom. Yeah, and see how I managed to get that working. Okay, so have a look at the and if you're not sure, there's a link here to help. Takes you to it, and there's a pH scale. Yeah, tells you, and look there. Okay. Oh, Hayden's putting a link. Stanley, you coloured it all in as well? Okay. Yes, Sophie. Sophie. Sophie's asking a question. You can turn your mic on and ask a question, Sophie.
I think we put it on in. I think, yeah, I put it on by accident.
Ah, that's okay. Okay, guys. So you're doing the worksheet, and if you finish the worksheet, you can watch the video. Yeah. And try and answer the questions. Don't worry if you don't get them right, because it's just an introduction at the moment. All right. So don't panic too much. Just watch the video. Yeah. Okay, so I'm recording this lesson for you anyway, so I'm going to put this video up later on. So if you dropped out the meeting or anything else, you can pop it back in. Okay, guys. Any questions? Lovely. In which case, have a wonderful day, and I will see you on Wednesday. So you're finishing the worksheet. Well done if you've done that. If you've finished the worksheet, you're doing you're watching the video. And there's a few questions in the video as well. It's more interactive. Don't worry if you don't understand it. We're going to go over it again, go over more stuff on Wednesday. We're going to do a Nearpod on Wednesday.
Bye, sir. Bye. 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 Bye.